Did you know the structure of coordination compound was explained in 1893 by Alfred Werner? Let's understand his famous theory in just 60 seconds. Werner proposed that metal ions show two types of valency, that is primary valency and secondary valency. So the primary valency is equal to the oxidation state of the metal and is usually satisfied by negative ions. So this valency is ionizable and it is located outside of the coordination sphere. So the secondary valency represents the coordination number. It is satisfied by neutral molecules or negative ions and is non-ionizable. Now we'll understand the Werner's theory by using this example. See the compound name hexaamine cobalt 3 chloride. So here the primary valency is 3 because there are 3 chloride ions are present outside the bracket, that is called primary valency. So this primary valency indicates the oxidation state of cobalt. Next secondary valency is 6 because there are 6 ligands are present in the compound. So this 6 ligands are represents the coordination number of the metal ion. So in this compound, cobalt has 3 primary valency and 6 secondary valency. Now see this compound and tell me how many number of primary valencies and secondary valencies are there in this compound. So here there are 2 primary valencies are there because 2 chloride ions are present outside the bracket, and secondary valency means here 2 types of ligands are present. One is amine and second one is chloride. Amines are 5 and chlorine is only 1. So 5 plus 1 is equal to 6. So secondary valency are 6. Like this you can easily identify the primary and secondary valencies in a compound. Now see some important questions from this topic. First question is which valency is ionizable? So which valency is ionizable? Primary valency is ionizable, which is present outside the bracket. And second question is which valency determines the geometry of complex? Secondary valency determines the geometry of complex. Next question, what does secondary valency represent? Secondary valency represents the coordination number of the metal. So how many number of ligands directly attached to the metal ion, that is the coordination number of the metal. Next, which ions satisfy primary valence? Usually negative ions like chloride, nitrate, these ions are satisfied by primary valence. Now see the next question. In this compound, how many moles of AgCl precipitate will form? So here how many number of primary valencies are there? Based on that 3 moles of AgCl are precipitated. Next question, in this compound how many moles of AgCl will form? So how many number of primary valency are there? 2 chloride ions. So 2 moles of AgCl is formed.